So how many? This primitive cell has generated type of cell. It has made endothelial cells which line the blood vessels. It makes the fibroblast, which can make a lot of collagen and a lot of connective tissue. It can make osteoblast. It can convert into chondroblast. It can convert into adipocytes. And okay, there's one monkey which loves to be around the blood vessels. This is another cell which is made by, of course, this one, and it is outside the capillaries, but it is around the capillaries like this. If there's a capillary like this, it is like that around. What is this cell? You must be knowing it. You must be knowing it. Yeah. What is the name of this cell? This is called pericyte. Have you heard of it? Okay, you will hear about it anyway. This is pericyte. You know why it is clinging there? It has very special services for the capillaries. What are its special services? That if blood vessel is damaged, they can multiply and make new endothelial cells as well as new smooth muscle cells. You know, blood vessel has endothelial cells inside, and larger blood vessels have smooth muscle cells outside. Do you know that or not? Okay, let me tell you. If this is a capillary, right? What are these cells? Endothelial cells, right? And then there is basement membrane. What is it? Basement membrane. And then outside it, there may be this very special monkey which love to cling with the around the capillaries. What is this monkey? Pericyte. What this monkey is going to do? Normally it is not doing anything, it is half asleep. Some people believe because it has a little bit actin and myosin, maybe sometimes it little contract and control blood pressure, blood flow, but it is not really that important. So you can ignore pericyte is there, just a sleeping, half sleeping monkey clinging with the vessels. But when vessel is injured, can this monkey remain asleep? It will wake up. It will start multiplying, and it will give rise to, what are these cells? Endothelial cells. Plus, it will also give rise to smooth muscle cell here and endothelial cells here. So what is this? Pericytes. Is that right? Again, pericytes are around the capillaries, and they are activated especially when they are injury to the vascular system, and they can help in the repair of vascular system. I told you that connective tissue has one function of repair. Is that right? And they can help in repair of vessels by providing the vessel with additional endothelial cells and smooth muscle cells. Then I said there is fibroblast. Fibroblasts make a lot of collagen and reticular cells and elastic cells even, and produce a lot of ground substance. So they are the grandfather of the connective tissue. Then I say there are some cells derived from their osteoblast, which make a lot of collagen and then a lot of ground substance which gets calcified, and that is formation of bone forming cell. In the same way, cartilage forming cells. Then adipocytes. Now these cells permanently live in different types of connective tissues, osteoblasts or endothelial cells, or fibroblasts, adipocytes, chondroblasts. They are permanent resident, right? Because osteoblasts live in the bone, but they don't visit the blood, or do they? They don't. But now we'll come to the monkeys which visit there. But one monkey we did not discuss, a very, very sensitive monkey. There is a very special type of very sensitive cell in the connective tissue. You have to tell me the name of the cell, but I will tell you first few features. That cell is extremely sensitive. You do the tissue, any type of damage, that cell is activated. For example, you damage my tissue by mechanical injury, or damage my tissue by thermal injury, by temperature, extreme temperature, or damage my tissue by chemical injury, or damage my tissue by radiation, or damage my tissue by microbiological injury by bacteria, or you do immunological injury. You do any type of injury, to the connective tissue, and that monkey will jump around and become very active and produce lot of products, and tissue will get inflamed, right? I will draw that monkey. That is not really monkey, but very, very sensitive. Touch me not. Very, very sensitive monkey. Of course, it is a cell with you, right? It is present in every connective tissue except central nervous system. Nature has been very wise not to put such sensitive and moody type of cell in the brain and the spinal cord. Is that right? But all other body connective tissue is very much rich with this cell. It's a very big cell, right? And very, very sensitive cell. You just do any type of injury on his back and it will start producing very different type of products, right? And this is one single cell which you are supposed to know if you have studied connective tissue, because it is problems with this cell produce a lot of diseases like anaphylactic shock, like allergic asthma, like hay fever. Please tell me mast cell. Very sad. This is mast cell. So all these monkeys are the permanent resident of these are the citizens, you can say, of the connective tissue business, right? Then there are, of course, I will go into detail of mast cells and other cells later, right? I'm just making first basic concepts. Then we come to the visitors, the wandering monkeys, right? Which may come to the connective tissue or may leave the connective tissue sometime, right? Or there are special supply of monkeys from the hematopoietic cells, hematopoietic tissue, and those monkeys are wandering in the blood, and whenever tissue is injured, they also jump into connective tissue. What are those monkeys? You know them, but you don't want to share your knowledge. I know it. Okay, let me tell you. When cells divide, this was hematopoietic stem cell. It divides into basically two types of cells. Lymphoid stem cell and another type is myeloid stem cell, right? There's lymphoid stem cell and there is myeloid stem cell. It means this stem cell can also maintain its population. This stem cell can also maintain their populations. Now, lymphoid stem cell can give rise to three types of cells. Yes, who will tell me these three types of cells? T lymphocytes, B lymphocytes, and natural killer cells. These are special type of monkeys which are present in the blood, and they can also visit the connective tissue. What are these cells? T cells, T lymphocytes, B lymphocytes, and natural killer cells. I told you one of the function of the connective tissue is defense mechanism, right? When tissue is injured by bacteria or something, then what happens? That connective tissue should be able to recruit some monkeys and play defense against bacteria. So there are lymphocytes. Now these lymphocytes can also visit, what is this? Connective tissue. For example, listen, that if you remove the epithelium of my skin and under that you find a connective tissue of my skin, in the connective tissue cell of the skin, you will find some lymphocytes there. But these lymphocytes may come into skin, live there for some time, and then they will leave to some other tissue, and more lymphocytes will come. It means they are not permanent resident. Usually they are on the visit visa. Is that right? So T cells, B cells, and natural killer cells. Then myeloid stem cells make another series of cells. There are, yes, what is this? RBCs, Yes. What else is there? Platelets. These are platelets. Right, they remain within the circulation, right, until circulatory system is ruptured. But the other cells, which can come out of, they are also derivative from the myeloid cell. And these cells are white blood cells. But one white blood cell we have already discussed is lymphocytes. The other white blood cells are, yes, granulocyte. What is the meaning of the granulocyte? The cells with specific granules. Some white blood cells have special type of granules. When bacteria come, they kill the bacteria by that granules. They are like hand grenades. Is that right? They have special type of granules. So those white cells which have specific type of granules, they are called granulocyte. They are called granulocytes. In the granulocyte, there are three types of granulocytes. These are all granulocyte. One granulocyte have multilobated nucleus, and other granulocyte is as if it is having, looking to you through its glasses, and other has kidney-shaped nucleus. This is having granules which take which color? Red color, eosinophilic color. And this granulocyte, when it is stained, it takes blue color. And this granulocyte, it has granule which take, some take blue color and some take red color. Now these granulocytes are special type of white blood cells, right? These granulocytes which are having glasses with red granules, what are these called? Eosinophils. They are eosinophils. Eosinophil mean what? Eosin mean pink dye, red color dye. Phil mean loving, red color loving cell. This is a white blood cell, but its granules are stained with pink color. So we call it eosinophils. And it loves which color? Blue. So we call it basophils. And this takes blue, its specific granule take blue color as well as red color. So what we call them? Neutrophils. That's very good. Neutrophils. So what are these? All of them are white blood cells which are having specific granules. They are having specific granules. What are these white blood cells? Neutrophils. What are these? Eosinophils. What are these? Basophils. From where they are coming? By the hematopoietic process. Is that right? Yes, please.
Are they all called leukocytes then?
All of them are called, okay. He's asking, are they called leukocytes? Yes, white blood cells are also called leukocyte. Leuko means white, cyte means cell. Leukocyte, white cells. Clear? Okay, I will make a little classification here. White blood cells are of course what? Leukocytes. Leukocytes can be divided primarily into two types. Granulocyte and non-granulocyte. What does it mean? All white cells can be divided into two groups. White blood cells or leukocyte with specific granules and leukocyte without specific granules. Am I clear? Now, leukocyte which are granulated, they are divided into three. I think now you remember your friends. What was this? Eosinophil. And what is this? Basophils. And it takes both colors. What is it? Neutrophils. So of course, these are leukocytes or they are white blood cells. But what type of white blood cells? Granulated white blood cells. And other are non-granulated white blood cells. Non-granulated white blood cells are divided into two. One has kidney-shaped nucleus, other has a nucleus which is almost filling the cell. These features you must know because they help you to recognize the cells. Any white blood cell which is full of nucleus and very little cytoplasm, That is called lymphocyte. What is it? Lymphocyte. And white blood cell with kidney-shaped nucleus and some granules which are not specific is called monocyte. Monocyte. So again, listen, it's not very difficult. We say white blood cells are coming from the bone marrow. Bone marrow is making red blood cells, platelets and white blood cells. Clear? These white blood cells are granulocyte and non-granulocyte. Granulocytes are having specific granules, non-granulocyte do not have specific granules. Granulocyte, some granulocytes have bilobed nucleus with eosinophilic granules. What are these? Eosinophils. Some granulocytes have kidney-shaped nucleus with basophilic stain on the granules. What is it? And some white blood cells have multilobated nucleus. Nucleus has multiple lobes with both type of, what is that? Neutrophil. And other white blood cells may have some granules, but those are not specific granules. Non-granulocyte means they do not have specific granules. They may have some non-specific granules. They don't have special type of granules. One of them have very big nucleus. And what is this cell called? And other has kidney-shaped nucleus. What is it? Monocyte. Is that right? Now, these are the monkeys on visit visa. All of them are coming from bone marrow into blood, and whenever tissue is injured, they may go into tissue. And these are very strange. These monkeys go into jungle when jungle is on fire. But they are the firefighters. They are the firefighters. They know how to fight. White blood cells. Is that right? So connective tissue cell include all these cells also. Am I right? So we can say that when tissue is injured, lymphocytes can go there, granulocytes can go there, and of course I did not make monocyte. Monocyte is here, and this should also go to the tissues. Is that right? Yes, please.
Which one would be considered macrophages?
Yeah, it's a very important question. I'm going to tell you. This monkey, what is its name? Monocyte. It is normally moving in the blood all the time. But if due to any reason, it leaves the circulatory system and go to the jungle, its name is changed. Monocytes into jungle are called macrophages. Monocytes outside the circulatory system are called macrophages. Monocytes, when they go out of the circulatory system, they are called macrophages. Is that right? Why we call them macrophages? Because when they are circulating, they don't love to eat the things. But when they go to jungle, they'll start eating big things. Macro things are eaten. So, macrophagocytosis. You get it? When monocyte come into tissue, into jungle, it has a very big mouth. It eats big things. It can eat group of bacteria. So it has power to eat macro things. So we simply call it a cell which has a special quality of macrophagocytosis. Or simply they call it macrophages. Macro means big, phages mean eater, big eaters. Is that right? Then there must be some micro eaters also, small eaters. You understand it? Monocyte is a monkey which is circulating in the blood, but if it has a special call from the jungle, you know who gives the call when jungle is injured? This naughty. Mast cells give a call to these cells, come here. Right? Anyway, we'll talk about that later. So, when monocytes go to the jungle, they start eating the dead cells, they start eating the bacteria, and they start eating the foreign body. If by injury some foreign body is there, so they have a capacity to eat big things. So they are called macrophages. So do you think there should be microphages also? Yes, there are. You know what are those cells? Which eat a little by little, which are called microphages, not macrophages. Neutrophils. Have you heard of neutrophils? Neutrophils are the cells, white blood cells, which come into the site of injury and they eat in a small way. So they are also called macrophages. And monocytes, when they enter into injured zone, right, they eat in a big way. So they are called macrophages. So we have a break now, and after the break we'll continue. Now we will discuss the connective tissue cells in proper detail. One of the very important cell is mast cells. So we'll discuss mast cells into detail. Why I'm discussing mast cells into detail? Because they are playing a role in many physiological and pathological processes. You remember there was one monkey which was very, very sensitive. Whenever tissue is damaged, it jumps around and produces a lot of products. That monkey is called mast cells. Mast cells is present in all the connective tissue of the body except in central nervous system. That brain and the spinal cord does not have mast cells. And connective tissue in all rest of the body is very rich in mast cells. Right? Now about the mast cells, first of all, let me tell you how they work. I will draw one mast cell here. Let's suppose, okay, we start a story that will help you to understand how the mast cells work. Mast cells play a very, very important role in allergic reactions, especially in type 1 hypersensitivity reaction. You have heard of allergic asthma? You have heard of that? Allergic asthma, right? So the major role is played by the mast cells. Or have you heard of anaphylactic shock? Someone was given penicillin and person was sensitive to penicillin and died within few minutes. Again, the major player was mast cells, right? So in many types of allergic reactions, mast cells are the major players. So we can take one example that how mast cells work, right? We can take this boy because he's sitting very near. His name is Rahil, and we see that he's going to develop allergic asthma. And we call it asthma or asthma? Asthma. Okay, whatever you call it. Right? In my country, they call it asthma. I think you call something else. Anyway, you understand in asthma what happened. That person who has allergic asthma, when he is exposed to the allergens, he develops difficulty in breathing because there is obstruction to the airflow and bronchial tree constrict. Now, what really happens? How mast cell producer trouble? Let's start with a very basic concept. Let's suppose here is Mr. Rahil and he goes to visit a special garden with his girlfriend. Okay, he has a girlfriend. So with his girlfriend, he goes to a garden and it's spring season and lot of pollen grains in the air. He's in a very flowery mood, right? And he's inhaling pollen grains, right? Now, most of us, when we inhale the pollen grains, our macrophages destroy the pollen grains and don't react to the pollen grains. But he is the unfortunate person who is going to develop an allergic asthma to the pollen grains. How exactly it happened? Let me draw. You have it? I don't know. Right. So now you'll know what is really going on in your lungs. Right? Let's suppose this is his lung and these are his airways. You know, airways, bronchi break down into smaller bronchial airways, right? Now, what I do, that let's suppose he has inhaled the pollen grains and pollen grains are coming down. These are the pollen grains. Now, when pollen grains are going down, of course, they are not going only in his respiratory system. Pollen grains are also going to his girlfriend's respiratory system as well. Normally what happens, a healthy person, when pollen grains or pollens are going in their lungs, here they are having special type of macrophages. What are these macrophages? There are special type of macrophages in respiratory system. These are called alveolar macrophages and bronchial macrophages. You know what these macrophages are doing here? They're all the time patrolling in the respiratory lining. And whenever some pollen grain comes or some bacteria come, they will phagocytose that and digest that away. This is the normal duty of macrophages which are present on the lining of the respiratory system. Is that right? Now what happens? Let's suppose here is this macrophage and here is the pollen grain. Suppose pollen grain. Now, this is the pollen grain. Normally what happens that when pollen grains go to your respiratory system, macrophage will phagocytose it. After phagocytosing, this is the phagosome. Macrophage will have special type of granules in which they have destructive enzymes. These granules are called lysosomes. Macrophage normally have lysosomes. What macrophages do, they catch the pollen grain or bacteria and make a phagosome and then empty these very dangerous type of enzymes into phagosome. So when these enzymes from lysosomes go into phagosome, they digest away the bacteria or digest away the pollen grains. Let's suppose if this macrophages in some other person who is not going to develop allergy, it will work in a different way. The pollen has come in, here is pollen, here is lysosome, both of them fuse and take the destructive enzyme here. Destructive enzyme completely destroy pollen grain. For example, proteins of pollen grains will break down into amino acid. Carbohydrates of pollen grain will break down to monosaccharides. So pollen materials are destroyed in most of you. But person who is going to develop allergy, something unfortunate will happen. What is that unfortunate? If you are going to develop allergy against the pollen, then what happens? That you have taken the pollen antigens, right? You don't break it completely. You break it only partially. You only break it partially. And after that, macrophage, unfortunately, fuse a special type of protein molecule with this and present this pollen antigen with a special protein on their surface. This is very sad thing. Normally what should happen? Pollen should be taken by macrophage and completely destroy. But the person who is going to develop allergic reaction, what is the unfortunate thing? That person will take the antigen of the pollen, bind it with special type of molecules and express it on the surface. It means this antigen is not completely destroyed. Unfortunately, it is very proudly presented to the immune system that look what we have caught, and we have taken this antigen with the special molecule. This is called class 2 molecules, MHC class 2 molecule. So with class 2 molecule, this antigen is presented to the other lymphocyte. What happens? Some lymphocyte will have a receptor to recognize this is a protein on the lymphocyte which can bind with the antigen. Suppose protein component of the pollen. So this protein is called receptor of T cell. When receptor of T cell will bind with what? Pollen antigen, and other molecule from this cell, from this lymphocyte will confirm that it is the pollen properly presented with class 2 or not. Again, listen carefully. This is lymphocyte. What is this? Macrophage. Macrophage caught the antigen, processed the antigen with class 2 molecule, presented to the lymphocyte. Lymphocyte recognizes the antigen with its receptor and recognize that class 2 with special molecule. Right? Now, if lymphocyte recognize this offer of macrophage, lymphocyte become active. This is T helper cell. I will not go into detail. This T helper cell will produce some product. And those products will stimulate B lymphocyte. They will stimulate, what is the cell? B lymphocyte, T cell helping the B cell. And B cell will become active and they convert into a cell like this. This cell is called plasma cell. This is called plasma cell. Please remember, plasma cell is not in plasma. It has nothing to do with plasma. Plasma cell is a B cell which is activated. What is plasma cell? It is an active B lymphocyte. So what macrophage has done? Macrophage offered the antigen to the T cell T cell activated the B cell and converted them into plasma cell. Plasma cells start making antibodies. What plasma cells start doing? They start making antipollen antibodies. What are these antibodies? Antipollen antibodies. Now what has happened to Rahil? That he is now changed. He is a person who is having antipollen antibodies in his body. He is different now most of other people. Right? Now, this antipollen antibodies which are produced by the plasma cells, they will go into blood and into local lymph nodes, and these antibodies love to stick to the surface of mast cells. This is now point to understand that once his body is having antipollen antibodies, if here is a mast cell, this is a mast cell has receptors, special protein receptors on its surface. Mast cells have receptors on its surface, and on these receptors, what can bind? Antipollen antibodies. They only bind, the receptors on the mast cells only bind antibodies belonging to IgE class. So this antibody which is made against the pollen, this belongs to which class of antibodies? IgE class. You will study that in higher classes. So what happens? That Rahil has a problem now. That he has stupid type of macrophages which did not destroy the pollen. They rather process the pollen and present it to the T helper cell which activated B cells, converted them into plasma cell and made antipollen antibodies of IgE class. Now antipollen antibodies will bind to his mast cells. Now mast cells are loaded with antipollen IgE. But up to now there is no allergic reaction. Up to now there is no problem. It was his first exposure to that pollen. It was his first lifetime, first exposure to that pollen. All this process, taking the pollen, presenting antigen to T cells, and T cells stimulating the B cell and plasma cell and antibody formation, and then loading the mast cell take about 2 weeks. It whole process take about 2 weeks. After 2 weeks, he is in a very, very dangerous situation. Why? Because in his lungs, under the epithelium of bronchial system, let's suppose I make a very large bronchial, these are what cells? Suppose epithelial cells. Under it, here are the connective tissue and mast cells. What are these cells? Mast cells. These mast cells are loaded with antipollen IgE. Is that right? These mast cells are like loaded guns. And when they will trigger? When next time again pollen will come. Because next time when again pollen antigen comes, these cells are having antipollen IgE and pollen will bind here. Now look here. Here is pollen antigen will bind here and here. And pollen antigens will cross-link IgE on the surface of mast cells. And this will activate the antibodies. And when antibodies tail are activated, when antibody bind with the pollen, antibodies are activated, they activate receptors. Receptors give signal to this cell. These receptors give signals. Signals are at 3 levels. They activate the cell membrane, they activate the cytosol, and they activate the nucleus. Now you see how mast cells are going to produce troubles in his life. That when allergic substance came again, he was a person who was having mast cell loaded with the anti-pollen IgEs. As soon as allergic substance came, within few minutes it activates the mast cells, and this receptor gives signal to the membranes, they give signal to the cytoplasm, they give signal to the nucleus. And after these signals, what will happen? in the cell membrane, there is an enzyme called phospholipase A2. This enzyme is activated. You know what it will do? It will break down the lipids of its own cell membrane. Imagine a woman who is very angry and irritated. She keep on pulling her own hair and start throwing it away. Mast cell behave like that. When it is irritated, activated, it breaks down its own lipids from its own membrane and throw away the pieces of its lipids. So what will happen? Its membrane is stimulated, membrane enzymes are stimulated, they break down the lipids in the membrane, and those lipids break down into two types of product: prostaglandins and leukotrienes. Have you heard of them? Prostaglandins are coming from the cell membrane. Leukotrienes are also coming from cell membranes. So what will happen? That in this area, lot of prostaglandins are released and leukotrienes are released. Now, these were connective tissue cells which are activated from their membranes. Prostaglandins and leukotrienes are released. What these prostaglandins will do? Prostaglandins will dilate the blood vessels. Blood vessels in this area will open up. Blood flow will be less or more? More. Let me now draw a section of bronchial system. I open a let's suppose this is the airway. Air should be here, right? Here are his epithelial cells, mucosa, isn't it? Bronchial mucosa. Under it, he has some connective tissue in which there are, what are these? Yeah, blood vessels, right? Here are some bronchial, what are these? Glands. They can produce secretions. Am I clear? You see how the real trouble starts due to activity of mast cells. These are smooth muscles around it, bronchial smooth muscle. And this is the whole bronchial system. You know, it's a section. Here is your nasty mast cell. When this mast cell is activated, it is releasing prostaglandin and leukotrienes. Now what happens? Prostaglandin open the blood vessel. So blood flow in this area will become less or more? More. When blood flow is more, fluid in this area will become more and tissue will swell up. When this tissue will swell up, it will swell inward. So air flow will become more or less? Yeah, so number one, mucosal edema. What is happening? Mucosal edema. This is problem number one. Problem number two, these are the leukotrienes. Leukotrienes act on endothelial cells and shrink them. You know, these are endothelial cells like this. When leukotrienes work on them, they become like shrunken. They shrink and there are gaps made. So more fluid coming out of vessel. Tissue will more swell up. Number one, blood vessels open. Number two, the cells which are making a lining of capillaries, those cells shrink and gaps develop and fluid will come out. More swelling of all this tissue. Is that right? Then, meanwhile, another trouble will start. From the, what is this? Granule in the mast cell. These are preformed chemical substances in this. These are called primary mediators of allergy. This, as soon as cytosol is stimulated, these products also come out. What are these products? Histamine. Have you heard of it? And there are eosinophil chemotactic factor, neutrophil chemotactic factor. Histamine is released, then some substances are released which will attract the eosinophils, some substances are released which will attract the neutrophils. It means this is a monkey which is producing some attractive substances so that eosinophils jump into tissue, so that neutrophils jump into tissue. It is calling more monkeys into this area. Blood is passing through this area. It was having white blood cells. Mast cell is here. It has produced the product here which will attract the eosinophils out and neutrophil out. It's a good news, bad news? Bad news, because eosinophil will come and damage the tissue. Neutrophil will come, also damage the tissue. These are not decent monkeys. When they come out into tissue, they start fighting and produce dangerous substances. Is that right? Then histamine. This is histamine. You know what it is doing? It will dilate the artery further. Plus histamine will shrink these cells further. All this is good for him or bad for him? Bad for him. Is that right? At the top, histamine has a receptor on these bronchial smooth muscles. The bronchial smooth muscle will constrict. When all of them will constrict, it will become narrow. So what is happening? The dangerous product from very moody type of monkey, mast cell. It is stimulated when allergic substance bind with the IgE on the mast cell. IgE activate membrane. Membrane produce prostaglandins and leukotrienes. Prostaglandin produce increased blood flow and increase permeability. Plus prostaglandins also produce bronchoconstriction. Constricted. Leukotrienes also increase permeability by shrinking the cell. Plus leukotrienes also constrict these cells. Prostaglandins stimulate the gland to produce more secretions. Now look at it, so sad. More secretions coming here, lumen is blocking. All tissue getting swelling, lumen is reducing. The smooth muscle contracting, lumen is further reducing. Airways becoming narrow. How many things are opening the blood vessels? Histamine is opening the increasing blood flow, as well as prostaglandin increasing blood flow. How many things shrinking these cells, endothelial cells, and increase the permeability? Prostaglandins and histamines. Then how many cells, things which are stimulating? What is this? Bronchial smooth muscle. Prostaglandins constrict them. Histamine constrict them. Leukotrienes also constrict them. It's a good news or bad news for him? It's bad news. Then gland also start working more. So more secretions here, number one. More edema and swelling here, more constriction here. Right? And still mast cell is not satisfied. So after a little more time, its nuclear machine will become active. And nuclear machinery will make messenger RNA, which will translate into proteins, and new proteins will come out here. Interleukin 1 and tumor necrosis factor. They will also increase the inflammatory processes here. At the top, from these granules, destructive proteins will come out. They are called proteases. What are these called? Proteases. They will destroy some tissue here. So what is happening in his lung? It's all monkey business. Right? That mast cells are irritated and they produce the product from the membrane, prostaglandins and leukotrienes. They produce the product which are already stored in granules, histamine, eosinophilic chemotactic factor, neutrophilic chemotactic factor, and proteases. Because they are already preformed, these are called primary mediators. What are these called? Primary mediators. Meanwhile, membrane products are coming as well as from nucleus. Nuclear activation orders the cell to produce more dangerous proteins, interleukins 1 and tumor necrotic factors, because these are synthesized later on. So these two are called secondary mediators. Again, mast cell produce primary mediators and also produce secondary mediators. What are primary mediators? Primary mediators are those substances which are already present in the mast cell before activation. These are ready-made, preformed. If someone comes to your home and you offer the cake which you did not eat yourself, it is a primary presentation. And then you cook something and offer. What is that? Secondary presentation. Mast cell is also like this. It has pre-formed materials, primary mediators, and it can synthesize new things and release. These are secondary mediators. All primary and secondary mediators which are produced by the mast cell in the bronchial system, they produce swelling of the mucosa, they produce increase glandular secretion, and they produce bronchoconstriction. So his bronchial airways will become wide or narrow? narrow. So can he breathe well? So he will find difficulty in breathing. So we say he has dyspnea. Dyspnea is difficulty in breathing. With that, his airways will become a little bit narrow. So they behave like small whistles. You know whistle? For example, this is a pipe, and if you make it a little narrow at one point, it may start whistling. Because when it is narrow, air will pass through, become turbulent, and may approach the speed of sound. So now, normally when he is breathing, there is no whistling sound. But because many areas in his lungs, mast cells are activated, and bronchial constrictions occur in multiple areas, as if nature has produced, or mast cells have produced many whistles in his airways. And you will hear whistling sounds from his chest. That is called wheezing. So this was one example that how important are mast cells in their function and how do they work. Now let me tell you another example. Where are mast cells specially concentrated in your body? Listen. Mast cells are specially concentrated under all epithelia. You know, under the epithelia there is connective tissue. So all the connective tissue which is just under the epithelium is very rich in mast cells. Plus, all the blood vessels, small blood vessels, outside the blood vessels, mast cells are well concentrated. Now let me tell you a more dangerous example what happens to mast cell. Imagine, if I'm having allergy to penicillin, and against the penicillin, I have made IgE. If I have made IgE antibody against the penicillin, then all the mast cells in my body are loaded with anti-penicillin IgE. Again, listen. Unfortunately, I'm a person who is allergic to penicillin. Why am I allergic to penicillin? Because, unfortunately, I have made IgE antibodies against penicillin. Now, this IgE antibodies which I have made against the penicillin, they will load all my mast cells in the body. Is that right? Now, one day I go to hospital, and there's a young doctor there, very enthusiastic, and he want to give me penicillin but does not check the allergic reaction. He directly give me intravenous penicillin. What will happen? Penicillin will spread all over my body, and it will go to every mast cell, and mast cells are loaded with anti-penicillin IgE. All my mast cells become active all over the body, and they start releasing membrane products. They start releasing the product from the their granules, mast cell granules. They start releasing product from their nuclei. Now you see what will happen. All my clinical problem will be according to the tissue in which mast cells are activated. Now in this classical example, you have injected the antigen or penicillin into my blood. So it will go all over the body. Penicillin will spread all my body. So all mast cells are activated. Now see what will happen. Number one, all the mast cells under the skin will release histamine and their product. So skin will swell up. You are getting it? I will develop swellings and redness in the skin. We call it rashes. I will develop multiple rashes due to allergy to penicillin. This is not a big deal. The real problem is those mast cells which are around my blood vessels, they will produce a lot of histamine. All my blood vessels in the body will dilate. And you know what will happen? Let me tell you. This is my heart and this is my circulatory system. Heart is the pump which is moving the blood. How much is the capacity of circulatory system? Anyone? What is the capacity of circulatory system? 5 liter. And what is the volume of blood? 5 liter. It means in a normal person, capacity of circulatory system is 5 liter and volume filled is 5 liter. It means circulatory system is full. Is that right? So when heart pump in this direction, of course something come back. Clear? And it keep on circulating. Now you imagine, mast cells are fired. These are the mast cells. They produce histamine. All my blood vessels dilate. My blood is still 5 liter, but capacity becomes suppose 10 liter. So blood will settle into the, will it go back? So heart will not get the blood and its cardiac output will drop, and my blood pressure will drop, and I will go into shock, circulatory shock. It's so simple. Mast cells are so dangerous because all the blood vessels are having a lot of these nasty monkeys around them. What are these monkeys? Mast cells. They're very irritable monkeys. And when you gave me penicillin touched these mast cells where? On IgE loaded on the mast cells. All the mast cells around my blood vessels release their product like histamine and prostaglandins and others. These products dilate my blood vessels. Blood vessels increase their capacity. When they increase the capacity, volume is now normal, but capacity is too much. This difference between the volume and capacity drops the pressure, and I go into circulatory shock. While I'm going to circulatory shock and my skin has developed rashes, mast cells in my lungs will also degranulate. And what will happen? Breathing difficulties. Now I'm a man. After the injection, I develop rashes. My blood pressure is going down. I find it difficult to breathe. And I develop abdominal cramps. Why? In the GIT mucosa lining, there are a lot of mast cells. They also fire. And GIT motility becomes disturbed. And I develop pain in abdomen. So what is happening? Before death, what are my problems? Just before death. Difficulty in breathing, rashes on the skin, abdominal pain, and then blood pressure goes down, and then I pass away. Is that right? This is called anaphylactic shock. Anaphylactic shock. Why I'm teaching you this thing in detail? Because these are clinically relevant and important. It's better not to irritate mast cells. But the question is that why nature put the mast cells there? Nature is a master creator. There must be some good thing. Yes, there is. Nature has put mast cell not for allergic reactions. Not for allergic reaction. Nature has put these monkeys that whenever you damage the tissue, mast cell produce product, open up the nearby vessels, call the neutrophil and eosinophils, right? So that whatever is damaging the tissue, for example bacteria, they should be eaten up. Actually, mast cells are there with all good intentions. That whenever tissue is damaged, they are very sensitive. I just give you example, mast cell can be stimulated when IgE is activated. But mast cell can be stimulated by any type of injury. I told you mast cell can be stimulated by thermal injury, by mechanical injury, by microbiological injury, by chemical injury. Any type of injury to the tissue will activate mast cells. Usually it is a good thing because whenever you, for example, some bacteria enter in my skin, bacteria damaging, local mast cell will be activated. Local blood flow should increase. More white blood cells should come there. And mast cell produce chemotactic factor. The white blood cell come into tissue and eat up the bacteria. So normally they are good. But sometimes, unfortunately, when we make IgE antibody against common substances, then mast cell become loaded with IgE and then they react against the allergic substance. That is a problem for us. Have you heard some people have allergic rhinitis or allergic conjunctivitis? Okay, some people, for example, one person goes to the garden and he develops red eyes. Another friend goes to the garden, he develops red nose. Another goes and he develops allergic asthma. All of them have problem with the mast cell, which are loaded with antipollen IgE. The only difference is the first person has a mast cell loaded with IgE in conjunctiva. Second person has mast cell loaded with IgE in the nasal mucosa. Third person has mast cell loaded with the IgE in the bronchial tree. What does it mean? It means that if mast cells are irritated in conjunctiva, you will develop allergic conjunctivitis. If mast cells are activated in the nasal mucosa and pharyngeal mucosa, you will develop allergic rhinitis. That is also called hay fever. And if you have mast cell loaded with IgE in the bronchial tree, you will develop asthma. And if you have mast cells loaded with IgE all over the body, and then you give allergic substance into the blood, person will develop anaphylactic shock. Another classical example of anaphylactic shock is by insect bite. Have you heard of it? That some people by simple insect bite simply die? Why? Yeah, because simple bee sting or some other. For example, we also get sting by the bee, but maybe we get little bit problem and then things become okay. But some unfortunate people take the venom of the bee sting, process in the macrophage, proudly present to T helper cell, and they activate the B cell, and person has IgE against the bee sting, bee venom. Now this person, when the next time beautiful bee will visit and sting, his mast cell in the body will be activated. And if these mast cells are activated under the skin, he will develop only rashes. But if they are activated all over the body, he will develop anaphylactic shock.
Would it have to be circulatory?
Yeah, if you have to develop anaphylactic shock, then an allergic substance should go into general circulation all over the body. You have a question?
How do some people outgrow asthma? When they're little, they have it, and when they get older, it's not as bad.
Yeah, that's a very interesting question. She says that as children grow, they grow out of asthma most of the time. The reason being, they say that bronchial system become less reactive to the product of mast cells. For example, in childhood, there are more receptors for leukotriene on the smooth muscle. As you grow up, receptor become less, so you are less reactive to the products. So you grow out of asthma. It does not mean that as you grow, pollen disappear from the world. It simply means your own tissue has become less reactive. Thank God.
So,
Yes.
is there a way to somehow remove the IgEs from the
Yeah, there are many ways to manage these allergies. We'll discuss in senior classes for sure. Let's have a break.